Yes, dear friend, now there are two questions on the board. One question is a rocket is fired from the earth towards the sun. At what distance from the center of earth the gravitational force on it will be zero. Mass of earth 624 kg, mass of sun 230 kg. Orbital radius of earth orbit of the orbit of earth is 1.5 10 to the power 11 meter. Second question, two stars each of radius 10 to the power 4 kilometer and one solar mass 230 kg are at rest at distance of 10 to the power 9 kilometer. Due to gravitational pull, the two start moving. What will be the speed of each just before they collide? So question number one says, suppose question answer one. It is the earth here, it is the sun here. Distance of sun and earth is 1.5 10 to the power 11 meter. So rocket is fired, suppose at distance x at point P. So gravitational force will be zero. Why? Because pull of earth, यानी कि gravitational field intensity of earth equal to gravitational field intensity of sun, दोनों equal होंगे. तो net field gravitational field zero. Suppose at distance x meter from earth, the pull on rocket is zero. This is only possible if gravitational field intensity of earth and sun are equal and opposite. Mass of earth ME, mass of sun MS. So if this distance x, this will be 1.5 10 to the power 11 minus x meter, and hence G into ME upon x square equal to GMS upon 1.5 10 to the power 11 minus x whole square. G cancels mass of earth. Now putting the mass of earth and sun here, we'll get 6 into 10 to the power 24 upon x square equal to 2 into 10 to the power 30. Actually, this question is simple. I am solving here so that you get the technique of solving such problems easily. Otherwise, student took it 2 3 6. So 3 upon x square equal to 10 to the power 6. This will go down to power are subtracted when we divide upon 1.5 10 to the power 11 minus x. Generally, what the student do? They start taking square, opening whole square. To open whole square, you know what step here. What you can do? Take a square root. taking square root on both sides. Both sides, you will get root 3 upon x is equal to 10 to the power 3 upon 1.5 10 to the power 11 minus x. 10 to the power 3x is equal to root 3 into 1.5 10 to the power 11 minus root 3x. This root 3x will be carried this way, or it will be x 10 to the power 3 plus root 3 is equal to root 3, you know value 1.732 into 1.5 10 to the power 11. Actually, while we add this, so root 3 is negatively small. Here root 3 is negatively small. Negatively small as compared with 10 to the power 3. So 10 to the power 3x is equal to 1.732 1.5 10 to the power. So x is equal to 15 to the 33, 45 or 3, 48, 4, 105 or 4, 9, 110, 25. Decimal after 4. 4 into 10 to the power 8 meter. So nearly it is equal to 2.6 10 to the power 8 meter away from Earth. The pull on the rocket will be 0. Therefore, you can say here that root 3 to negative here also. No, it is multiplication. It is addition. So while adding or subtracting, we can neglect. In multiplication, we can't. Now, second question is there, which is a very good question. These questions are from NCERT book. These are from NCERT. You have listened to it. So, 2 stars each of radius 10 to the power 4 kilometer and 1 solar mass each. 1 solar mass of sun के equal उनका mass है. They are at rest at distance of 10 to the power 9. 2 stars 2 into 10 to the power 30 and other 2 into 10 to the power 30 meter kg. These were the masses. So they were at rest. The radius of each is 10 to the power 4 kilometer. How many meter? At this distance will their center 10 to the power 9 kilometer. So they are at rest. You are asked when they just start moving and just when they collide. What is their velocity? So initially, these 2 stars, M mass each, M, are at rest. Which energy do they possess? They possess only potential energy, gravitational potential energy. And due to force of attraction, they move here. And when they collide, distance between their center, this distance becomes 2 into 10 to the power 4 kilometers. So when they reach here, just before colliding, which energy will be there with them? The kind energy and their potential energy. Due to gravitational force, initially they have only potential energy. Here they have kinetic energy as well as potential energy. So if velocity of each be m, then from law of conservation of energy, energy can either be not destroyed sum of their potential energy. Potential energy here will be equal to sum of potential plus kinetic. यानी कि half mv square होगी of 1 and into 2 minus gm square upon potential energy of 2 mass का formula है u equal to minus gm1 m2 upon r distance between them. So here two masses are there. So gm1 m square distance 2 into 10 to the power 4 kilometers, 2 into 10 to the power 7 meter. This will be equal to the initial potential energy minus gm square upon 10 to the power 12 meter. It is kilometer here. Convert that into meter, multiply by 1000. So from here you have to find out this velocity. These two get cancelled, or mv square is equal to gm square upon 2 into 7, this side plus minus gm square upon, now m square get cancelled, so v square equal to gm upon 10 to the power 7, you can take common 1 by 2 minus 1 upon 10 to the power 5. Do you understand it? What I have done? I have taken gm upon 10 to the power 7 common, so 1 by 2. To take common is to divide. So when you divide 10 to the power 12 by 10 to the power 7, so you get 10 to the power 5. G 6.67 10 to the power minus 11. Mass of star 2 into 10 to the power 30 upon 10 to the power 7. 1 upon 2 minus, you know what is this? I mean 1 lakh, यानी कि it is 100,000. So this term is negligible. So neglecting here 1 upon 10 to the power 5, you will get here v square equal to, this 2 get cancelled, 6.67 into 10 to the power 18 to 10 to the power 12. So v equal to under root 6.67 into 10 to the power 6 meter per second. It is big problem for student here to find square root of decimals. I keep on telling again and again, so you please be very careful what I tell, because these problems I have noticed in my teaching experience. Under root 6.67. So you know, square of 26, square of 27, 659. But I am telling, while taking the square decimal, we make pair this way. Here this is 2 to the 4, 2.67. It is 4. We have 2 here, last digit. 4, 6 are 24. 4, 6 are 24, 6 are 30. 27. Hardly it is equal to this. So it is nearly equal to 2.6 10 to the power 6 meter per second. Sufficiently large speed. So when actually we have seen shooting stars. What are shooting stars? They are not stars. There are asteroids. No? So they, when asteroid and other like comets, some parts of comets come in the attraction of Earth, and when they move towards us, they enter that atmospheric tremendous speed, and due to friction, they get burnt. So that is that speed, 2.6 10 to the power 6 meter per second. You can say it is 2.6 10 to the power 3 kilometer per second. not small speed. It is 2,600 kilometer per second. So I explained this question to you so that you understand the technique of doing the problem. Though I have noticed nowadays arithmetic ability of student is very poor. बहुत गड़बड़ है. अभी I was teaching in class and students were not able to subtract this. They were looking horribly on this question. Subtract. They told me it is 10 to the power minus 8, 10. And they know that when we multiply only power are added, when we divide power are subtracted, even though they don't think what they have learnt once कि पावर ऐड होती है बस ऐड कर जाते हैं. तो दिस वे प्लीज बी सीरियस. I will do more question later on. There is a big number of questions in this chapter and lot of topics are left untaught.